Hi everyone, I'm Cheryl. In this problem, we're asked to find the fluid force of a plate that's submerged in water. Now in this particular example, our plate is a 2x2 square and it's being submerged vertically. So that means that different levels of the plate will have different amounts of pressure because it will be at different depth levels. So to find the fluid force, we're going to need an integral. So to do our integral, we're going to need the weight density, the depth, the area of my representative element. So let's go ahead and take a look at a representative element. It's going to be a little rectangle that goes across here. Now, notice I don't have a Cartesian plane on my picture. I'm going to put one on, and the interesting thing is that I can locate that Cartesian plane anywhere I like. It's going to change the way the formula looks depending on how I orient it, but it won't change the final result. So I'm going to put my axes straight down the middle of my plate and across the bottom edge of my plate. So I now have an X and a Y axis, which will help me calculate some of these depths and areas. So let's go ahead and look at that representative element again. I need to find the depth of this element. Well, if this depth is at Y, notice that the depth of the representative element is going to be at 4 minus Y. So for my integral, I have, first of all, the weight density, which I'm in the metric system, so that's 9,800 newtons per cubic meter. My depth is going to be 4 minus Y. And then the length of my representative element, because it's a square, is just 2. And then the width is going to be represented by the dy. And notice what happens with this representative element. I have to add up all of the fluid forces for my representative elements and take infinitely many of them. That's what creates my integral. And I'll be integrating from 0 up to 2. All right, I've got my formula set up. Now I have to do the integration. So the first thing I notice is that I have a 9,800 times 2. And that's a constant multiple, so they can be pulled outside of the integral. So I'm going to have 19,600 times the integral from 0 to 2 of 4 minus y dy, which gives me 19,600 times 4y minus y squared divided by 2, evaluated from 0 to 2. We begin by plugging in my upper limit. So I have 19,600 times 8 minus 4 divided by 2 is 2. And then I have to subtract what happens when I plug in the lower limit, 19,600 times 0 minus 0. So I have 19,600 times 6. I'll use my calculator to do a little number crunching. And I end up with 117,600 newtons. I hope that was helpful. Thanks.